In this video, we'll see how to automate the Terraform KMS module or AWS KMS module by using the AI. Before starting the before going to the automation, now let me go through a little bit about KMS. What is the need of KMS and why you are using KMS and what steps we should follow to complete this entire project using AI. Here we are using Codex AI. This is the high level idea. In the next video, I will show the practical implementation. Now just look here. Why do we need KMS? What is the importance of KMS? KMS, you know, it is an encryption mechanism. By using KMS, we can encrypt our data. Okay. Without KMS, if there is no KMS, right, in the application level, we should have some mechanism to do the encryption, store the encryption keys, and it is a risky task because you should not keep your key on your application code. Then with KMS, what happens? AWS owns and protects the key material. Your app calls KMS APIs and access is controlled by IMA plus the KMS key policy. We should not, application owner or application team should not worry about the storing the KMS key or any key on its code. Why? Example, suppose a payment service encrypts customer reference data. Before storing it in a database, the service gets cyber text from KMS API, AWS KMS API, but never stores the raw encryption key on its code. Now here, in this lecture, only will focus more about the symmetric KMS keys. There are different types of KMS key given by AWS. The symmetric key basically, by using the same key, the data can be encrypted and also decrypted. That is the purpose of symmetric key. Symmetric means only one key you have. By using that same key, you have to encrypt the data. Also, you have to decrypt the data. Who can access the KMS key? Now look here. This is the key, right? This is a important parameter, or you can say important security concern. So I have to set a mechanism who can access my KMS key and who cannot access my KMS key. Suppose there is an application called payment application. There is a dedicated KMS key is created. Only that payment application can access. Other application cannot access or other user cannot access it. Okay. So how you can do that? That we can achieve by using IMA permissions plus key policy trust. Here in AWS or in any public cloud, right, you have multiple organizations or you have multiple engineers, different engineers are working. First one is my KMS key should be accessed by the admin engineers. Now admin engineer are controlled by the admin role. That means I have to give the KMS access to the admin role. Next one is the application team, right? Application is consuming my KMS key to encrypt the data. That means the app role should have access and that access is limited. Limited means as compared to admin, it should be admin can enable, disable, rotation, everything can be done by the admin. But your app should have permission only for encrypt and decrypt. And also we have audit engineers, audit people. There is a dedicated role called audit role that is created for the audit engineers. What they can do? They can only inspect. And remaining all other users, they should have a deny role. They cannot access that KMS key. Parameters required to generate the KMS key. Okay. So when you are creating a KMS key for your organization, it should not be very simple. You should make it production usage or you should follow the best practice. When you are creating the KMS key, first you have to mention the description properly. Why this KMS key used, who is using, who will use in future also. That is called description. Next one is called, we have to specify the alias name. Alias name. Suppose this is called production KMS or it is a database KMS. We should properly mention a name, alias name. Next one is called, we also set the deletion window. Suppose someone is deletion windows in days, that should be also mandatory parameter, because if someone accidentally deleted the KMS key and that KMS key used for the data encryption, that data, once the KMS key is deleted, you can't decrypt the data, you can't restore the data again. Hence we should add the deletion window. Even if today I'm deleting, it should be deleted after 30 days. Within 30 days I can restore it. Next one is called key rotation. That is also important parameter, right? Why key rotation? Because look, whenever this key, suppose one KMS key, this KMS key is used in the production database. If that KMS key is compromised, then it is a risky. For that reason, we have to, within some time period, we have to rotate the keys. Then also we have to manage the tags so that my audit engineer can easily track it. Next one is important part is key policy. Once key is created, we have to add the policy. Policy means who can access. My admin can access, application engineer can access, audit engineer can access. That is called key policy. We have to set in the KMS. Now this is called, okay, so this is about the, now this slide is basically about the KMS. Now next part is, every day I am getting the request from my application team, audit team, HR departments. Oh, I need the KMS key. Can I manually go and create it? No. So it is a time consuming process. Instead of that, what you can do, you can use a concept called Terraform. By using Terraform, we can create a KMS module, and I can share it with my engineers. They can create their KMS key as per their requirement. And when we are creating the Terraform module, it should be a proper structure. Once the KMS key, this is the structure, reusable module slash KMS. Inside the KMS folder, it is holding all the Terraform files. And also, once before publishing to my engineers, I should test that module thoroughly, whether it is really application engineers, admin engineers, audit engineers are able to access it or not as per their boundary. Other engineers, they should not access it. How you can test it? There should be a test tag should be also there. Now just imagine if I'm writing this entire Terraform files manually, it will take lot of time. Also, when you are testing, you have to test manually one by one. It is also time consuming process. Hence, to implement this entire module, KMS module, we have to take the help of AI. Here we are using Codex AI. By using the AI, within 30 to 40 minutes or 1 to 2 hours, we can achieve our task. We can complete our task. Now look here, how testing works with multiple IMA roles. Okay. Now once the Terraform apply is done, a Terraform apply means once your KMS module is created, then we have to create a KMS plus roles. Then we have to assume the roles. Assume means application, you should act as a application engineer. Then see whether you are able to encrypt, decrypt. You should assume you should assume as a admin engineer. Then you can see whether you are able to do admin related activities on that KMS or not. Also, you can act as an audit engineer. Only you can do the read access. So that you can do through the CLI, AWS CLI. And it is a very complicated task, right? Because I have to suppose 3 roles, I have to create it manually. Then I have to give the permission. I have to test. It is a very complicated task. The same entire flow can be done by the AI. Okay. The next part is, this is the final test case. Once the KMS is created, once the module is created, I have to do positive test, negative test onto that KMS. Then I have to publish it. If my positive case is passing, negative test also passing, then only I have to publish to my engineers so that they can use it. The next one is, then how you can, this entire problem statement, how you can achieve through the AI. You know, AI completely based on the prompt. Prompt means instructions. We have to give the instruction, hey, I need this. This is my problem statement. Can you completely do this task for me? That means this is a set of group of instructions. Prompt is nothing but group of instructions. I have to instruct my artificial AI to do this activity. First of all, the first step is any prompt, right? whether you are creating for Terraform or any Python developer, anything. First you have to set the scope. Scope means you have to tell you are a define the role. Role means what I have to tell. I have to tell, hey, before AI, who was doing that activity? A Terraform engineer or a senior DevOps engineer or a infra engineer. First of all, I have to tell you are a Terraform engineer, senior Terraform expert, or you are a senior DevOps engineer. Can you do this task for me? You have to include the project structure. The next step is I have to tell the file structure. My file structure should be my file structure. If I am going to my previous slide, right? This is your file structure. There should be a folder called module/kms. Okay, let me go to that slide. Okay, this is called your file structure. You should create a module/kms. It will keep all the Terraform files. Also, it should create another folder called module/kms/test. It should create a test folder. This is called my project structure. I have to tell to my AI, this could my project structure should be look like this. Next one is when it will create the when it will start creating, right? When it before starting creating, it will what parameters it will keep. It should keep KMS key, alias, variables, outputs, locals, provider requirements, and validation rules. Next one is key policy contractor. This is super important because this is a security engineer basically do, right? Model is root, admin, application, audit, explicitly denied, unlisted role behavior. That also I have to specify to in my prompt so that accordingly AI will create. I will tell create 5 roles and I will tell who can these 5 roles, right? 5 roles means 5 types of engineers. And then I have to tell the scope, which engineer can do what. The next important part is test stack roles. Once everything is created, you have to do a test, positive test and negative test as per the roles created. After that, it should give some the outputs so that I can record that output for the future reference. Next one is my positive test. I will tell how the positive test should happen. It should happen through Python script or it should happen through AWS CLI. That also I have to tell. Another case is my negative test. Okay, negative test means again I have to tell how you can do the negative test, how you can write, how you can implement so that negative test can happen. That instruction I have to give to AI. Then AI can do something for me. Next one is entire testing flow. Okay, this is about your brief level idea about Terraform AI. Okay, then the next video, okay, if you'll see, if I will go to the complete prompt, right, it is very difficult. This is called my complete prompt. If I'll explain this complete prompt and execute the Terraform, start creating the Terraform modules validation, it is very difficult to understand, right? For that reason, what I'm doing here, I have this entire prompt, I have divided into multiple steps. What step 1 it will do? In the step 1, it is basically the you have to set the role. Step 2 is called your file structure. Step 3 is called what parameters it should keep. Step 4 prompt is about the policy contractor. Okay. Step 5 is called about your testing, how you can perform the testing. This is basically the prompts. I have divided the big problem into small problems. At the end, if you will merge these steps, you are able to complete your task by using the AI. Step 5 prompt basic instruction, basically what it does, a test task. Okay, how it can perform the test. Next one is called what output I should get. Next one is called how you can do the test, positive test, how you can perform the negative test, then entire complete workflow. Clear? This is about prompt. In the next video, I will show how you can execute step by step all the instructions and finally you can achieve your task. That way, you can understand how the prompt, how you can design your own prompt, not only for Terraform, in the all the use cases, and how you can execute for the, how you can give that instruction to AI so that your AI can complete your task. Okay. Thank you guys.